Hi students, in this video we will talk about the scientific notation in chapter 8. So why do we use a scientific notation? What does it mean? Sometimes we need to deal with some large number and very small numbers. Say the Sahara Desert, that will be the area will be very large, and the number of stars in the galaxy is quite a lot amount. And maybe like a virus, the size will be very small, and the pollen grain of the maize will also weigh a very small amount of grams. So if we need to read and write all these numbers each time, it is very inconvenient. So what should we do? We want to simplify these numbers. So how to simplify these numbers? We can represent these numbers using the power of 10. For example, number 10, we can say it is 10 to the power 1, 100 is 10 to the power 2, 1000 is 10 to the power 3, and 10,000 will be 10 to the power 4. So if we have a very large number, look at this number. Can you express this number as the power of 10? You can count the number of zeros in this number. Altogether 12 zeros. So you will say that 10 to the power 12. How about other kind of numbers? Let's say 5,000. How could we express it in terms of the powers of 10? First, we have to say that 5,000 is 5 times 1,000. And we change 1,000 into 10 to the power 3. So 5,000, we can say that it is 5 times 10 cube. How about 41,000? We would change it into 4.1 times 10,000. 4.1 times 10,000. And we change 10,000 into 10 to the power 4. So we get this number equals to 4.1 times 10 to the power 4. How about a small number? 0.1, we can say that it is 10 to the power negative 1. 0.01, it is 10 to the power negative 2. 0.001, 10 to the power negative 3. And the last one, it is 10 to the power negative 4. So if we have this kind of number, we can also count how many zeros are there, including the first one. There are all together 9 zeros. So this number, we can say it as 10 to the power negative 9. So we can express this small number in the power of 10. 0.004, we can say it is 4 over 1,000. And then we change over 1,000 into times 10 to the power negative 3. So it's actually 4 times 10 to the power negative 3. And this number, 0.00063, we can think it as 6.3 over 10,000. And it means that 6.3 times 10 to the power negative 4. So the answer is that. And we can say that these values as scientific notation, they are written in scientific notation. Alright, so we will try to look at this. And remember, in scientific notation, the term before the power of 10, that means here is A, small letter A, it must be 1 to 10. 1 to 10, including 1. And n is an integer. We use an integer for the index. Let's say originally the number is greater than 10. So the power will be a positive power. For example, 5,840, we can change it into 5 5.84 times 10 cubed. 5.84, it must be a number between 1 to 10. If the original number is greater than 0 but less than 1, then the index will be a negative index. For example, 0.00092, we will change it into 9.2 and then calculate how many zeros before it. There are 4 zeros, so it multiplied by 10 to the power negative 4. 10 to the power negative 4. These numbers are between 1 and 10. So try to find out that A to F, which are expressed in the scientific notation. You can see A, D, and E are the answers. But for B, C, F, the first term is not, is not between 1 to 10. So they are not expressed in scientific notation. So previously we used to have these examples, and there will be a quick way to obtain the number. Do you know how? So you can count the decimal point. So you move 3 places to the left for 5,000, because originally there is a decimal point at the end of this number. So you can find that, that will be 5. And as you move 3 places, the power will be 3, 10 to the power 3. For this number, 41,000, the decimal point moves 4 places, so the power is 10 to the power 4. And this one, it moves the decimal point will move to the right by 3 units, 3 places. So the power will be negative 3. And the last one, the decimal point altogether, you move it 4 times. So the power will be 10 to the power negative 4. So we can follow these steps to express the number in a scientific notation. First, you locate the position of the decimal point. For example, there are 5,000. We try to locate it. It is the end of the number, and we move the decimal point so until it is after the most significant figure. In this number, 5 is the most significant figure. So you can count how many places moved. It moved 3 times. So the number will be 5 times 10 to the power 3. For a number smaller than 1, not greater than 0, count the decimal point, it moved 4 times. So the number will be 6.3 times 10 to the power negative 4. And we have some negative numbers. We can also express it in the scientific notation. Like these 2 numbers, you can also write it as in the scientific notation. So can you find the value for this in scientific notation? Part A, there's 270,000, and you can change it in 2.7 and times 10 to the power 5, because the decimal place moved 5 times. And the part B, you can count it, it should be 8 times, and the first term is 8.39 times 10 to the power 8. So on and so on. This one, the decimal point, it moved 5 times, and you get 7.2 times 10 to the power negative 5. And the last one, you can count that the decimal point altogether moved 7 times, and the first term will be 5.18. 5.18 times 10 to the power negative 7. So these are the answers. Okay, you can also express these into scientific notation. So remember the method that you used. Okay, and then we try to express these back to the original number. So 3.9 times 10 to the power 5, back to the original number, it will be 390,000. Okay, so because you move 5 decimal points. And for this number, 2.74 times 10 to the power 4, and also maybe you can use the computer, but I would use the calculator, but I will talk about it later. And for A2, 2.74, actually it's multiplied by 10,000. So it will be 27,400. Okay, how about this one? You change 10 to the power negative 7 back to the decimal number, then you can find it back. Count for the zeros. And for this number, you can also change it into this way. So you can say that there will be altogether 9 zeros before 4. So 0.00000000438. We have another question. How to express the following in scientific notation? And you can look at that for part A, 421 times 10 to the power 5. Remember, this one is not in scientific notation because the term 421 is not between 1 to 10. And we have to change it. 421, you use it in scientific notation. So we change it into 4.21 times 10 squared times 10 to the power 5. And then we multiply 10 squared and 10 to the power 5 so that we can get it would be 4.21 times 10 to the power 7. And part B, 0.00038, it is not in scientific notation. You can change it as 3.8 times 10 to the power negative 4, so that 3.8 times the power will be 10 to the power negative 4 minus 2. So it will be 3.8 times 10 to the power negative 6. So you try this follow-up question. The first one, you can change it into 4.3051 times 10 to the power 4. So the answer will be 4.3051 times 10 to the power 10. For part B, okay, and also you have to round off your answer to 3 significant figures. So 4.31 times 10 to the power 10. And for part B, it will be 9.128 times 10 to the power negative 3 times 10 to the power negative 4. So altogether, it will be 9.128 times 10 to the power negative 7. But you have to round it off to 3 significant figures. So the final answer will be 9.13 times 10 to the power negative 7. So that's the end of this video. Next time we'll talk about how to do addition or other subtraction of these number in scientific